Hi, in this video I'm looking at adding and subtracting vectors from each other. So we're going to have a look at how do we take two vectors and add and subtract them. So let's just look for theoretical for now. If I have a vector A, say this vector here, A, and I have vector B, say this vector here, vector B, I want to know what is the result of adding these two vectors together. Now, one of the things about vectors is because they can be used to represent positions from one place to another, we can almost turn this into a journey. If I start at the start with vector A, if this is my sort of start, and I travel by vector A, and then I add on vector B, I end up traveling and switching along vector B, and then I want to know what is my resulting from that, which would be from my start back to where I finished, which would be that vector there, which would be our resulting vector. And this gives us what's called the triangle rules, or the triangle rule for vector addition. And it is that if you have the sum of two vectors, A and B, you join them together head to tail. So we go head to tail joined here, and the result of the addition is the vector from the start to wherever you ended. So if we want to use this in an example, say I have a block sitting on a surface. So if I have a block sitting on a surface and vector, well, I got one vector which is coming out horizontal parallel to the surface, and it's say 7 newtons at an angle of 0 degrees. And I've got another vector working on this block, and it's coming out, it's 5 newtons, and it is at 58 degrees to the horizontal. And I want to know what is the resulting vector of these two forces. So what happens if I add these two forces together? What direction is the block going to try and travel in? So to do this, we use our addition principle. I can draw out, say if I call this vector A and I call this vector B, then I can draw vector A is 7 newtons on a bearing of 0 to, well, an angle of 0 degrees. So that's vector A. And then I can add on vector B, which is coming up here at 5 newtons. It's not to scale. And this is at an angle of 58 degrees. I want to know what is my resulting vector R. What is the result of adding these two forces together? So this is not a right angle triangle. We've got a horizontal line meeting a 58-degree line, and this is most definitely, even though my diagram's to scale, it's still not a right angle in there or up there. So I've got to start thinking about using my sine and cosine rules to figure out this problem. So if I have a look, I need what I've got an angle on the outside of my triangle. I need an angle on the inside of my triangle. And if I use the fact that, well, this is a straight line here because 7 was 0 degrees, so we translate that through, continuing on, 58 degrees, come around some more, this would be an entire 180 degrees from this point round to this point. So we can do 180 minus 58, which would give us 122 degrees in there, because that's 180 minus 58. So now that we've got that angle, I can start looking at using my sine and cosine rules. So if I call this angle B, say, and we call this angle A, and this angle C, that means my resulting, it's going to be a little confusing, maybe I'll change my letters a little. I'll call this angle C and this angle A. So that means that this is going to be side C. And so we would have the cosine rule, which says that C squared equals A squared plus B squared equals, not equals, minus 2AB cos angle C. So now, actually I'm even going to change the names here. I'm going to get rid of angle A and get rid of angle B, just so that my names line up nicely. So I'm going to change this to B, so this is side B, and this to A, so this is side A, just so it lines up with my vector names. So that means I've got C squared equals A squared, which is 7 squared, plus B squared, which is 5 squared, minus 2 times 7 times 5 cos our angle C, which is 122 degrees. And so if we go and put that into our calculator, we get C squared equals 111.09 continuing. And if we then square root that, we get C, which is the square root of 111.09. Then C will give us a force of 10.54 newtons. I just need to know what direction is that pointing in, because I've only got the magnitude so far. A force is a vector. So now I've got to start looking for angle, which means that I need this angle in here. I want to know what is angle, in this case, angle B. So that means I can move to my sine rule, because now I've got an opposite side and angle. I can move to sine. Well, we're going to have sine of angle C over side C equals sine of angle B over side B, which means that I am going to have sine of 122 degrees, because that's angle C, over side C. Well, we just worked out side C, that was 10.54. And sine B, well, that's what we're trying to work out. We don't know B, over side B, which was 5, which means that our sine of angle B is going to be 5 sine 122 over 10.54, which means that our sine B equals 0.402 and some stuff. And then our angle B is going to be the inverse sine, or the arc sine of that, which means that my angle is 23.72 degrees. So there we have it. Our resulting force, R, is going to be, so if we write this out, R, whoops, that's more of a B. Let's try to make that more of an R. R is going to be a magnitude of 10.54 newtons. So 10.54. And at an angle of 23.72 degrees overall newtons. So that means that really our block in this case is being pulled kind of in this direction, so it's going to be lifted off the surface a bit with a force of 10.54 newtons. So there we go. If you have to add vectors, we add them by putting them head to tail. So always head to tail. So we join tails to heads. So we form triangles, and then we can use our triangle maths to help us solve for magnitudes and angles of our resultant vector.